Everyone. Thanks for coming. We're just going to give a few minutes for everyone to sort out Zoom and filter in here, and then we'll get going. Mhm. Give it about another minute and see if a few more people trickle in here. Okay, that seems to be, I think, everyone, or at least a stable number for now. So I'd like to thank everyone for coming, first and foremost. If you have questions as we go, there's a question and answer at the bottom. Feel free to type them in at any time. We'll be doing a Q&A at the end. It'll be moderated by another member of the TankScope team, so they'll redirect those questions to me. That way you don't have to kind of remember them till the end. So feel free to use that as we go, and we'll try and hopefully address everyone's questions at the end there. So we'll get going here right away. So my name is Stephen Courtney. I'm the director of technology with TankScope. My background's in physics, but I've spent my entire career in storage tanks, storage tank cleaning, primarily initially, every part of it from running the shovel to the wash gun to planning and executing robotic and non-entry tank cleaning projects when that was kind of a newer part of the world there. And through all of this, there's kind of always been very similar issues that crop up in all of these projects, and it's just a lack of information about what is in the tank prior to actually executing these projects. It's a little bit like a black box on a plane. By the time you get the information you need, it's far too late. So we're going to talk a little bit about how to fix that and how to better manage storage tank cleaning and storage tank sludge in general. So, what do you really need to plan a storage tank cleaning project? And the answer is a lot more than you usually get. It's pretty common to just get given drawings. Honestly, I'm usually happy if I get drawings that are half the quality of this. Sometimes they look like they've been hand drawn and photocopied 100 times. And you tend to get that and maybe an SDS. And you're asked to put together a quote and a timeline and a budget. And that's all you really get. And very little information is given about what's actually in the tank. An SDS is representative of maybe what's in service at that time, but it's certainly not representative of the sludge, the other materials that have accumulated in there over the time. So, this is how we ask people to quote and plan these projects, and we're setting people up for failure basically right from the get-go. And it's just obviously not a good enough methodology. So we'll talk a little bit about how to better that as we go through this presentation here. So yeah, storage tanks represent a huge point of uncertainty in oil and gas operations. There seems to be a mentality that it is what it is when it comes to cleaning costs. I personally have written more change orders than I'd care to admit, and oftentimes it's not the fault of the cleaning vendors or the contractors on that end. If you're not given clear information, how are you supposed to put together a budget and execute that in a timely fashion? Imagine you were asked to quote a project where you're told there's basically going to be 12 to 18 inches of putting consistency slop in the bottom of a tank. You build your plan, you pick your equipment, you bring the crew out, and you pull the doors off, and there's 5 feet of packed sand across the floor of that tank. Like, what do you think that's going to do to your budget and timeline? And I can tell you because that's actually a true story, and it was part of the kind of inspiration for getting into TankScope and tank profiling, and just feeling like there had to be a better way. We often hear from clients timelines and budgets exceeding 400% of the set budget, and getting stacks of change orders that are continuously piling up, and it's really just not an acceptable way to manage these kind of circumstances. So we're going to start by talking about some of the historical methods of tank assessment. Historical is probably too kind of a term because these are still things I see going on in this industry almost every day. We come across similar types of tank assessment methods, if you want to call it that. The most common thing that you see on every tank is just historical tank tracking. And it's really just a nice way of saying, asking someone what was in the tank last time they cleaned it. I've been asked to call people who don't even work at the company anymore or are retired to figure out what was in that tank the last time they opened it. And, that's 20 years ago in some cases, and obviously retired and out of the business for a while. These are not accurate or reliable sources of information. Next thing we see a lot of is thermography. When done well, it can be a useful tool, but the truth is it's more of an art than a science at times, and we see a lot more bad thermal data than we do good thermal data that leads to inaccurate RFP, RFQ assessments. And even if you do get accurate data, it's really only indicative of what's going on right at the shell side of the tank, right with where the sludge is in contact with the walls. It doesn't tell you anything about what's going on any further into the tank than that. And the next thing we've seen, over the last couple decades is sonar technology coming out for tank assessments. It has a lot of limitations and can provide some pretty inaccurate data. In my experience, it's struggles with things like water in storage tanks, which is a natural product, a byproduct of crude production, and it's in there until it settles out and can be dewatered. It also struggles in low sludge environments, overrepresenting sludge, which can lead to completely misrepresenting the tank contents. And even if it is accurate, again, a little like topography, you're not getting the whole picture because you aren't getting the actual material samples, and it doesn't know the difference between an emulsion and a heavy sludge or different types of sludge in a tank. So that kind of it ties into the incomplete sampling idea. Like, it's not uncommon to get a sample off of a low valve or a water draw and have someone say, well, this is from the bottom of the tank, so therefore it's the sludge. Well, if you have sludge piled up against a far wall, obviously that's not representative of what we're trying to capture here, right? So what are the consequences of these types of planning methods? And the obvious ones, as we kind of touched on earlier, is change orders. I think that's something that resonates with a lot of people. Uh, and just the cost changing from what was budgeted, but not just that, but the project timeline extensions and having your tanks out of service for an extended period of time. Not being able to utilize that asset can be a much larger cost than even just the change orders and the extended costs in the field as well. The other thing is, safety incidents and environmental noncompliance. If you aren't actually quantifying what that material is, the hazards that are associated with that material in a real quantifiable way, then you can't say that you can actually build a proper safety plan or a proper disposal plan if you aren't actually getting accurate information about what that material is. So that brings us to the solution here. And we kind of see this as a three-pillar approach. Number one is volume assessments, but not just the volume itself, but a map of the distribution. Where is it located in the tank? Second is material characterization. So not just how much is there and where is it, but what is it? What is in the sludge? Is there hazards associated with that? Is there maybe good material associated with that? Oftentimes we see really high hydrocarbon percentages that could offset the cost of a lot of these tank cleaning projects that often go to disposal or otherwise are wasted. And that kind of ties into part three, which is the practical application. Once you have all this data, the volumes, the locations, the distribution, material characterization, what can you actually do with all that to improve storage tank management, storage tank design, and cleaning and sludge removal and recovery? So we're going to touch on all of these as we move through here. So first thing, as I said, accurate volume assessments. So expanding past thermography and to get a proper volume and distribution and topography assessment, you actually have to go and take data from across the surface of the roof and the tank area to build and integrate an actual distribution profile. You can get very accurate data this way, and it allows for much more accurate planning of tank cleaning projects. For example, even just from this picture here, right, you can see if you were to try and jet mix this in a standard way, you'd likely try and circulate it and or mix it from all the different quadrants of the tank. And really, you'd probably be wasting 2/3 to 3/4 of your time attacking sections of the tank that don't even have sludge, when you could really do a much more targeted approach and figure out where exactly you should be attacking this from and how to best manage this. And it also gives insight into the type of equipment. Will you have enough effective range to really reach this? Do you need to go through the roof? Do you, is there going to be something left for cleaning at the end? And then even some basic insight into, well, if we've got sludge accumulating here, maybe we can look at, better jet mixing nozzles or better mixers as we progress past the cleaning and into, you know, permanent sludge reduction, which would be, the goal. As nice as it is to have good planning tools, ideally removing the need for all of this would be the end goal. So looking past that, oftentimes characterizing just the heavy sludge material in a tank really isn't good enough. Oftentimes tanks will have areas of free water, over near a water draw. They can have a heavy sludge layer, a lighter sludge layer on top, and then even some kind of rag layer and emulsion. So oftentimes, getting all this information is key to actually assessing a tank for cleaning and maintenance. Really, the trick is here, you have to actually go through the vertical column of the tank and delineate each layer using properties of the material: density, viscosity, temperature, water content, looking for things that, separate these layers, and then actually capturing those individual layers and stratifying the tank in a fashion that allows you to capture each material and take those materials for assessment, right? This can also be really useful. Sometimes, come across tanks that people think don't have problems or are empty because there isn't heavy sludge material accumulated. But actually taking these kind of measurements can either prove that to be true or prove it to be false. Maybe you have a rag layer or something else that's harder to identify, but could cause issues in processing, or could cause issues in cleaning, or could be indicative of other issues upstream or cause issues downstream from that. So now you have a big, you've delineated your tank, you've got your individual samples of each type of layer. What do you do with all that information? And the next couple of slides here are kind of the meat of a lot of the material characterization stuff that we touched on. And we're going to cover as best we can, at a high level here, but we're always open to further conversations on it because I know there's a lot of dense material here. The thing that we see most commonly done for sludge is simply, your BS&W, which is a useful test. Oftentimes, for example, this was a real one. The numbers are a bit small, but you're looking at 84% hydrocarbon, almost 85% hydrocarbon that was slated for disposal. So now you're paying to remove it from the tank, you're paying to dispose of it, and you're basically losing all that perfectly good product. So you're paying for it in multiple ways, multiple times. That alone isn't good enough to assess blending and stability and a bunch of the other, to give you the best idea of what your options are for sludge management. And we'll touch on this a little bit more, but the goal is to break these things out as far as possible, right? So breaking your hydrocarbons out into its constituent parts and breaking your solids out into its constituent parts, which will actually show you if you have things like pyrophoric material in that tank, or maybe you have indicators of rust or other things. Sometimes there's things that you can find that really aren't supposed to be in there that maybe are coming from somewhere upstream. So you can really only, going beyond just the size of the particle and really looking at what's going on within this sludge, which is really always this combination of water and hydrocarbons and then solids that create these tank sludges. The other thing is, further chemical properties and assessing things like if there's different types of cutter agents or stocks or even scavengers that are being potentially used, like actually quantifying the amount of H2S so that you can figure out to the liter how much of that material you're actually using, so you're not wasting, totes of material, throwing them into tanks when maybe or maybe not you've captured that material and removed it safely. So I touched on a little bit of this, but what are the actual tests that give you this kind of information? The first number one key one is SARA testing. Saturates, aromatics, resins, and asphaltenes are what predict something called colloidal instability, which is really just a fancy way of saying like oil stability, two different types of oil, will they remain stable if you blend them together? So in these kind of tanks, the most common thing is to find a cutter stock and mix it and try and remove that sludge that way. And or sometimes even just a change of service, look at whether or not your oils that you have in different tanks are compatible, or whether you're going to drive some of these asphaltenes and other things out of suspension, right? Excuse me. Taking that a step further, that's really a predictive test, and you can do actual bench blend testing to assess the feasibility or to confirm the feasibility of different cutter stocks and actually apply that in a real environment prior to taking it to the field, right? Moving into the solid side, a lot of this is done. Particle size distribution is huge for things like filtration, picking the right size of filter, and not having either too much or too little. You can really get a good distribution of that. And then as far as breaking that material down further than size, it's a combination of scanning electron microscopes and X-ray diffraction, which I won't get into the details on here, but it allows you to actually quantify each type of material. And that's part of this image you're looking at. You can actually quantify all the different types of pyrophorics, all your different crystalline structures, and that will give you a lot of insight into what's going on and the tank processes that are involved, and then also the risks associated with that, right? So if you have pyrophorics, maybe that can be managed prior to the tank coming out of service. Maybe it needs to be managed during cleaning, but just having that knowledge going into this is key for a lot of this. So, in my opinion, only with all of that information do you actually have enough material now to properly plan and execute a tank cleaning project. And it's not something that I've ever seen when I was asked to do this kind of work, and it's not something I've ever seen elsewhere. Can actually probably predict out of service time. You can properly address the hazards, create proper safety plans, proper disposal plans. Maybe depending on the nature of the tank, if you look at the properties or profile several tanks, you can predict or make decisions on what's the best order of operations. Is one more problematic than the other? If maybe they can all be done in any order, maybe it's best to restructure them so you're dealing with the most problematic things first, and then dealing with some of the simpler things on the back end, but really, or vice versa. But at least you can make those decisions with a clear set of information. So you're not taking a tank out of service for allegedly a month and then having it turn into 6 months. Well, the other tank is now coming up for service, and you backed yourself into a corner, right? So I'm going to show you now kind of with a couple case studies how this kind of works in the real world and what it's looked like and some of the successes here with this kind of process and procedure. First case study here was two sister tanks that had been in similar service, and they've been rotated through different products over their lifespan, but closing in on 15 years. They weren't slated for inspection right away, but especially tank A had over 14,000 cubic meters. It was almost 20 feet of sludge, which is basically half the tank in that dark brown area here. So looking at almost halfway up the tank and almost half the tank of packed sludge, basically the consistency of peanut butter. You can see here the pretty standard sludge hydrocarbon breakout, 81% hydrocarbon, 9% oil, 10% solids. Uh, Basically, they were going to take this out of service because obviously there's some kind of issue going on here, but we ran through this procedure, pulled the samples of the sludge, and there's two or three other products that they looked at being able to store in here or use a cutter stocks. And we went through the SARA testing and did the blend testing and found something that was an extremely good match that actually broke this stuff up and allowed it to remain stable so that it could be shipped through the pipeline or something or moved to another tank, and it wasn't just going to drop out of suspension, because if you have unstable blends you might just be moving that problem to somewhere else, right? So all that was done here was a change of service to something they would have been storing anywhere, somewhere else anywhere, and the sludge chemically just melted out of this tank over the course of the coming months, and the sludge reduction on it was extremely high. And basically you're getting 100% of this material back, you're getting your storage space back, and you don't have to use any mechanical cleaning or mechanical methods just by having the information to do this kind of assessment, right? And actually figure out a better solution that maybe wasn't initially apparent. Tank B, as I said, is a sister tank. So come in, it's got a little bit less sludge down in the more 5,000 cubes range, but still a big problem up to 10 feet. The composition, if you were just looking at BS&W, looks fairly similar, right? And you know, you have black sludge from one tank, black sludge from the other tank. You know, they look the same, they seem the same. The initial reaction is, okay, well, we had this synthetic crude that worked magic on tank A, maybe it'll work on tank B as well. But basically, the actual chemical constituents of sludge in tank B was hiding a lot higher percentage of asphaltene, and it was keeping that suspended based on, again, the Sarah profiles, and it was actually a softer sludge, and to the eye would have seemed like less of a problem. But basically, if you were to mix the same synthetic crude, it predicted and did show that you would actually knock a layer of asphaltene out of suspension in this sludge, and you would have created a monster that was worse than the sum of the parts. This is just a solid layer of asphaltene that would have been created in trying to use the same methodology applied to two what you would think are similar tanks, right? And so that just shows the importance of each tank is different, and every tank is can have completely different results, even if you would assume similar results. So this was done with a more traditional jet mixing and mechanical cleaning, using the oil that was already in the tank instead of switching service, and also was successful, but just in a completely different way, right? Moving on to case study 2 here, it's kind of the opposite, and we touched on, you know, some of the poor um, techniques that are used that don't actually capture the sludge and take the samples properly and do this assessment properly, and the kind of results you can get there. So the this was a client, they had some poor thermal data, and more to the point was really inaccurate sonar data that told them they had 9 feet of sludge in most of the floor of their tank. And obviously they were, you know, made a big plan with a big OpEx budget for centrifuging and jet mixing and sludge removal, and it was coming out of service early. So this was a big problem. And we were asked to come down and take samples on this tank. And we ended up proving that there was no sludge in this tank, and they had been, you know, the sonar, the interference, whatever it is, had just returned false results. And we, you know, took actual density viscosity measurements throughout the whole column in multiple locations to prove that there was no sludge layer in there, took actual samples, and you know, these are sludge samples compared to the oil sample, and you can see they're both saleable oil, and did that in a variety of locations, and managed to get this tank delayed out for several more years because it didn't have to come out right away. So again, actually getting this information the correct way and the samples the correct way is key to all this. So just looking towards some of the other applications for having all of this type of data is computational fluid dynamics is something we integrate into our tank cleaning and planning, and even just storage tank design planning as well. So you can see here, this is an assessment of a certain size of sweep in a 200-foot, 20-foot tank, and you can see where the effective range of a system like this is, and where you'd have sludge remaining if you're going to just use this system. And then you can make assessments about, do you attack it from the roof with maybe a roof jetting nozzle, or is it okay, you're going to go in and get it. But maybe, you know, if you can prove that you don't have the effective range, this is a lot much cheaper and easier than trying to circulate a tank for 2 weeks just to find out that you are not having the effect that you think you are, because you know, you just don't have the critical velocity to break up that sludge or something like that, right? And so this is a very powerful tool, and given that we actually have, you know, the proper material data from the profiling side, you can get much more accurate simulations than you otherwise could, right? You're not guessing at the oil properties or anything else. The other thing that this can be used for is tank design improvements. So this was an assessment of an internal mixing system that was deployed, or was planned to be deployed. And basically you can see how the sludge would, or how the velocity in the tank would keep the sludge from accumulating in this kind of environment. And again, like, assessing these options up front and prototyping them this way is far more cost effective than deploying something like this and spending the money to put it in, cleaning the tank, and then figuring out that it's just not going to work the way you want it to, right? And the other big one for anyone who's worked in, the tank sludge reduction and cleaning side is heating. Oftentimes, heating sludge can help it melt and be removed from tanks, or help reduce it. But if you're trying to heat a big tank with a little hot oiler, it may not even be possible to get to a certain temperature. So you can assess, because of the massive surface area, right? It's often you're not adding enough energy to outpace the radiation coming off of the tank. And you can assess whether it's feasible to even reach that temperature. And if you can reach that critical temperature, kind of estimate how long it's going to take, or if you should change plans and maybe that's not the right method. So just touching on all of that here, we will be doing another webinar specific to CFD and the applications to CFD in above ground storage tanks specifically, and go into more detail on all this, some of the challenges, some of the positives, and all that. So keep an eye out for that as we move forward for the next few months. And that really just brings us to the conclusion here. So the hope here is to change the way you look at tank sludge, turning something that's typically a problem potentially back into a resource, or even a cost offsetting benefit. It's the goal here is to remove all of the guesswork, right? And to eliminate, at the core of this, to eliminate change orders. Something that I think everyone here is probably much more well versed in than they'd like to be. And so with this kind of information, there's some accountability that you have what you need to properly plan a project, right? And there's no guesswork going in, and there's no, well, you didn't tell us that this was here, and whatever else comes from that, right? So anyways, I appreciate everyone's time. If you have any questions, I will have Sean jump on here and join us to kind of manage the Q&A from that end. The QR code here is for the website, and if you have any questions, feel free to reach out by email. Take a look at the website as well. There's more information on the services and everything there. So
Hey, Steve. Hey,
hey.
everybody. My name is Sean Jewett. I work with the TankScope marketing team. And yeah, I'm just going to help read off a few of these questions for Steven. So, first question here, Steve. Are these services typically geared towards only crude oil storage tanks?
No, they can be applied to any type of storage tank. We've had success in everything from water and wastewater tanks for oil and gas storage. Crude oil tends to have a lot of heavy sludge accumulation, so we've seen a lot of value there. But no, the answer is any type of storage tank. This can prove to be a very valuable tool.
Cool. Next question here. Is there a minimum or a maximum size of tank to perform these services on?
No, it's more based on just access to get the types of samples you need. So, a fixed roof tank, even a smaller fixed roof tank, as long as you can get in and get the types of samples you need, even if you're somewhat limited on the amount of data points, you're still going to get a much more accurate volume assessment, and then you can get all the chemical material characterization that we kind of discussed as well. So that's no, there isn't.
Cool. I think you might have touched on this briefly, but here's another one. Does tank profiling show the possibility of a rag layer?
Yes, it does. We did touch on that a little bit, but basically, if the way that we take data in the field allows us to actually measure the density and viscosity at the time of sampling, and look for indicators of that kind of rag and emulsion layers forming, and then actually pull discrete samples of those layers and take them to a lab for testing, and then actually calculate volumes on those kind of layers as well.
Gotcha. Okay, here's another one. If there's a tank outage, say in 2026 or further out, is this viable?
Yes, as we kind of touched on in some of the case studies there, even just having that information earlier, it's possible to manage your sludge well in advance of even the tank cleaning side. Oftentimes, you may be able to get a lot of storage space back in the meantime as well, which could be very valuable. And even from a planning standpoint, right? I mean, the earlier the earlier you do this, the better, within reason, the better you can assess and plan which tanks need to be managed. And then, if it ends up being a long way out, just going back and doing a quick reassessment of the volume, just to verify if it's changed much, can be done as well. But having the heavy sludge material characteristics aren't going to change much over the course of a depending on the timeline. But yeah.
Cool. Here's another one. How do you get these data sets?
So they're actually going out onto the roof of the tank using whatever access is available. We've built most of the sampling tools proprietary in-house because there's just nothing available to capture. I mean, you're talking about so many varying densities. Capturing sludge like that and that kind of sludge material can be quite challenging when it varies in density so much, and then capturing actual discrete rag layers as well as discrete samples of the oil. So yeah, using whatever access we can get across the surface of the tank to do both volume assessments and then all of our own designed sampling equipment from in-house. So
Very cool. We have a question here. It says, will you be sharing the presentations? We will. Everyone should get a follow-up email just thanking you for joining the webinar. You should be able to view the recording of this webinar there. And then you'll also be able to watch it on our YouTube channel. That should be up tomorrow. You can access our YouTube channel just through our website, tankscope.com. We have another one here. This one's from Brent. What is the maximum height for you to be able to do topography and sampling? Can the tank essentially be full?
So it can be. It makes sample capture more difficult because you're pulling them from the roof level. The preference is to be closer down, but it can be done at any height. It typically just extends the timeline a little bit because it's just slightly more difficult to do, and it takes longer to do per point. But yes, it can be done at any height.
Cool. That's looking like it for questions. So unless anyone else wants to pop a final question in, that may be it. And yeah, just a reminder, we will send a follow-up email thanking you for the webinar. This will be available on our YouTube channel tomorrow. And I guess I'll leave it to you, Steve, to wrap things up.
Well, yeah, we really appreciate everyone's time today, and thanks for coming to the webinar. As I said, keep an eye out for some of the next ones. We'll be doing one specifically on computational fluid dynamics and looking to do some panels with other people in this kind of industry. So keep an eye out for those. If you have any questions, you want to discuss any of the technical side in more detail, or looking to take a crack at some of these services, don't hesitate to reach out to the team here. The email, the phone number, the website are all right there. So yeah, we really appreciate everyone's time today. Thank you.
Thanks. See you, everybody.